What's up, everybody? It's UziNets. Today's episode 7 of my series on computer networking. Today we're going over DHCP, port channeling, and LLDP. These are some really important protocols to know, so let's get into it. DHCP is Dynamic Host Configuration Protocol. What it's for essentially is configuring IP addresses to all your end devices. It makes it so connecting these devices is really easy, and it prevents IP conflicts that can happen from human error when you have someone trying to configure end devices with a bunch of IP addresses manually. It's really there to make everything much more simple. So how does DHCP work, you might ask? Well, they use DORA as an acronym, DORA. It stands for Discover, Offer, Request, and Acknowledge. First you have discovery. This is where the DHCP server discovers the client because the client puts out a broadcast address to the DHCP server. Then you have the offer. This is after the DHCP server discovers that request. It then offers the client the available IP addresses. Next, you have the request. This is where the client selects an IP address and it tells the server which address it wants. And last is the acknowledgement. This is where the DHCP server acknowledges the IP address the client wants and it lets them have it. Now we're going to go open Packet Tracer and I'll show you guys how to configure this. Here is our network for this example. We have 3 VLANs connected to a layer 3 switch connected to a router. I've already configured everything. The VLANs are all up. OSPF is up and running. The only purpose of this is to show you how to configure DHCP. So these are the commands we'll be using. We'll start with this first command, IP DHCP excluded address. This is actually an optional command, but for best practice, we'll implement it anyway. So we go into the switch, we go to switch config mode, and I've already copied these commands. I'll just paste them right here. So the command is IP DHCP excluded -address, and then you want to type in the first IP address you don't want to be used, followed by the last, and this will act as a range. And as you can see, this VLAN is a .10, this is a .20, and the bottom is a .30. So the first one I put 10.1 to 10.10, the second one 20.1 to 20.10, and the third one 30.1 to 30.10. This is an optional step, but it is best practice because in the real world, there's going to be times when you don't want certain IP addresses used because you might want to save those IPs for things like static routes. So I'll enter that. And so now when DHCP configures IPs, they won't use any of these addresses from .1 to .10. So now I'll actually configure the DHCP. I'm going to type in IP DHCP pool management, and I'm just naming it management because over here I put VLAN 10 is management, but in reality you can have any name you want. So I'll enter that. Next is the command word network followed by the network IP address and the subnet mask. There it is right there. 192.168.10.0 is the network address, and the subnet ends with a .0. Enter. Next is default router, and for this you want to enter the default gateway. So for this first pool, the default gateway ends in 10.1. I'll enter. I'll do DNS-server. For this example, we'll do 8.8.8.8. This is the universal default DNS server, and I'll enter. Now I'm going to repeat these commands for the second VLAN, the second pool. I have them copied and pasted in a separate note file. I'm going to paste them all at once, like that. And you can see right here, this pool will be sales because we have sales for this VLAN 20. The network is the same except it's .20 over here. Same subnet mask, ends in 0. The default router is 20.1. Same DNS server, and the exit, and I'll enter this. And I'll paste the third and final pool. Same deal. You can pause and take a look if you want to double check. Enter that. So now I'm going to verify by typing in this command, show IP DHCP pool. And there it shows you pool management, pool sales, pool engineering. Now what I'll do is go into these end devices. I'll go to the desktop IP config and I'll click DHCP and it says DHCP request successful. So now this end device is configured with DHCP. Now I'll check this one. Successful. And the last one. Successful. So that is how you configure DHCP. Next, we'll go into port channeling, aka port bundling. This is where you combine multiple physical links into a single logical link. And by logical link, I mean you combine them via software rules, not physically. This practice is widely used in networking. It improves redundancy, meaning if one line fails, the other 3 will still work. Bandwidth or the speed, and load balancing, essentially meaning there's a balance of data transfer between the ports. It's really there to help make things more simple. So if you take a look at this picture on the bottom left, this top connection takes 1 gigabit of speed. This bottom connection is 4 gigabits of speed. It's much faster, but it has 4 physical links. These 4 links add to the speed of the connection, but realistically, without port channeling, we'd have to configure all of these separate links with different subnets, different IP addresses, and so forth. This would make things super confusing. So this is why we use port channeling, to logically tie these links together so the device will view them as one link. The way port channeling works is through link aggregation, or the tying of multiple links into one, which we went over. Failure handling, meaning if one link goes out, the other ones can pick up the slack for it. Traffic distribution, also meaning the balance of transfer of data between the links. And lastly, it uses port channel protocol, and I'll show you what those are. So the main port channel protocol is LACP, Link Aggregation Control Protocol. This is a global standard used across all devices, across all networks. PAGP is Port Aggregation Protocol. It is a Cisco proprietary used only for Cisco devices. They both support automatic failover, which basically means that the links are dynamically managed. So if one goes out, the others that are connected will still make up for the slack, and they'll be automatically redistributed in terms of the balance of traffic, and the connection won't go out until all of the connected links go out. Now I'll show you guys how to configure a port channel. These will be our commands. First thing I'll do is add some layer 3 switches. I'm going to label out some IP addresses. These will be the IPs for the interfaces. And now we're going to add 3 links. First link, now the second link, and the third link. 3 links. First, I'll go into switch 1 to the CLI, configure terminal. First thing I'll do is type in IP routing. This way we allow routing on the switch. Now I'm going to create the interface. Let me move this here. This is our command, interface port dash channel 1. And this one can be any number, just like VLANs. You assign the number yourself, but just for the purpose of this, we're going with 1. Now I'm going to type in no switch port because it is a layer 3 switch. Now I'll type in this command, 192.168.0.1, 255.255.255.252, and enter. Now with one command, I'll go into all 3 interfaces. I'll show you how. This is the command to access all 3 interfaces in one go. Interface range fast Ethernet 0/1-3. So I'll enter. I'll do no switch port. And then I'll type in this command we have here, channel group 1 mode. And then I'll do active for the first one. And then for the next one, I'll do passive. For best practice, you want to have one active and the other passive. So channel dash group 1 mode active, and I'll enter. And the 3 interfaces went up. Now we'll go to the second switch. Into the second switch, CLI. So we already made the port channel, so I'll go into the port channel's interface port channel 1. I'll do no switch port. I'll move it over. And now I'll type in this command for this IP address, 192.168.0.2 enter. Now we'll go into the range of interfaces again. Interface range, fast Ethernet 0/1-3. Don't forget no switch port again. Now we'll do channel dash group 1 mode passive, and it's up. If I want to troubleshoot, I can type in show interface port channel 1. As you can see, it gives us the info, shows you right here the members in the channel, and then you can check that on the other switch, copy that, go into the other switch, check the interface, protocol is up, members. You can also do a ping test, so I'll ping 192.168.0.2, and it went 4 out of 5. Do it again for good measure, get a 5 out of 5, boom. And that is how you configure your port channel using LACP. And the last thing we'll go over, and this will be very quick, it's LLDP, Layer Link Discovery Protocol. This is a protocol that mainly has to do helping with network management, device discovery. Essentially, you configure a device with LLDP and its neighbors with LLDP, and then you're able to get information on all the neighboring devices. You get information like IP addresses, MAC addresses, port numbers, VLANs, all that stuff. So I will show you how to do that now, and then we'll wrap up. Now we're going to configure LLDP to finish off. First, I'm going to grab some switches. I'll grab about 5 switches. 1, 2, 3, 4, 5. Now I'll just randomly connect them, and I'll label the interface as I go so you can follow. I'll just go in a circle, and there we go. Nice pentagon. And I'll just add a couple random ones like that to this. I'll take this one, add it there. One more can't hurt, like that. Boom. You know what? I'll just do that, like that. And then I'll go from here to here just to make a nice little star. So now we're going to go into each switch and run LLDP run. Go into this switch, CLI, enable, configure terminal, and do LLDP run, and I'll type that into each switch. Actually, what I'll do, I'll just type this out here, copy it. Now I'll go into switch 2, and I can just enter and paste. Now the next switch, CLI, enter and paste, and enter. Fourth switch, CLI, enter, paste, and enter. And the last thing for the last switch, paste, enter. So now they're all configured with LLDP, and now to verify, I'll go into switch 1, and now I'll type in show LLDP neighbors. Now I'm going to enter, and I'll scoot this over. Now we're on this switch, and as you can see, this is the information of the devices connected to this switch. This first line is information on the switch at FA0/1, so that would be this switch. This is information on the switch connected to 03, that would be this switch. Then it shows FA04, that's this switch, and so on and so forth. You can also just type in show LLDP if you want to see if it's configured on this individual switch, and it is, status active. So yeah, that's LLDP. It's to learn information about your neighbor devices. It's a very important protocol in the actual field. Many times network engineers don't know the actual topology they're working with, so they use this command to kind of map it out for themselves. And that is also it for Packet Tracer today. And that is it for today's video, you guys. Thank you for watching. Hope you enjoyed it. Today we went over DHCP, we went over port bundling or port channeling with LACP, and we went over LLDP, These are very important protocols used in everyday life for network engineers. Thank you guys once again, and I will see y'all in the next video.